Hello Doug, we've got the transmission out of your 2004 GMC pickup. This is what it looks like when it's all apart. I'll go over some things that we found on the inside with you, and Eric or Amanda will contact you with the cost estimates. So we'll start with the pan. You can see on the magnet there's quite a bit of metal on there. We're not sure when the pan was dropped last if they would have cleaned that off. This is about 3 times the normal amount. There's always going to be a small skip there, but that's fairly excessive. If we look over here, you can see this black stuff. That's going to be clutch material. When we look at the clutches, this one's our low reverse clutch. You can see the steel plate is a uniform color all the way across, and the same thing on the friction surface as well. So this is the low reverse clutch. This one has not been slipping. This one is our reverse input clutch. The same thing, it hasn't been slipping. If we're doing a recondition, anything that has a paper lining like this would get changed with a new one. And we always use Borg-Warner frictions. If you look there, that's upside down, but Borg-Warner is the OEM supplier of clutch plates, so we always try to use the best clutch plate, and that's the one that works best in this unit. So again, very little discoloration on the plate, but no slippage really there. This one is the 3/4 clutch. It is burnt, so you can see the coloring of this pressure plate. That's from the extra heat. These steel plates are a darker color to start with, but and these are dark green lining, but the 3/4 clutch has been slipping, so there's been extra heat generated there. You can see our load release springs, they've kind of turned black. It's still hard to, the camera's hard to pick up on the actual color of it, but the springs themselves would normally be a natural color, of course. So and this is not terrible, but they've definitely gotten too hot. On the drum here, this is a reverse input drum. This surface where the band rise is going to be important for shift from second and also the shift to fourth gears. So the coloring on here is got a little bit of discoloration here, and that's going to be from the band slipping a little bit. The band itself is a dark green lining, so if you look, you can see, if you see where my thumb is, you can see it's kind of a green color, and then right here it's blackened. That's the slippage I'm talking about. So not terribly, it's not that it's failed, but you can definitely see the difference in colors there. The black is going to be where the slip actually is. This one is our overrun clutch, and same sort of situation, a little bit of slippage. You can see the hot spots on the steel plate there, and on the clutch plate itself you can see the blackening. That's going to be from the slippage. Again, not a failed clutch, but a clutch that's definitely slipped. This one's our forward clutch. This discoloration here is from the clutch wearing, so the clutch plates themselves are a little bit thinner. It's not from slippage. You can see the steel plate is a uniform color there, so the forward clutch wasn't slipping. These sprag races, they have a common issue where my thumb is, that surface gets rough. That's rubbing up against this race right here where my thumb is, so it's a fairly rough surface. What ends up happening is it'll wear away this material, and this brass is going to show up in the pan. So this one's not that bad, where we should be able to polish that up, and then we just flip the races, so this one becomes the bottom race, the other one becomes the top race. So we have a new surface going up against that surface there. So not a huge deal, but if there was some brass in the pan, that's going to be a reason why there. Also polish this surface so it's a much smoother surface to try to stop any of the brass grindings from getting into the pan. The sprag itself looks okay. We don't see any extra wear. There's a line, the camera's not really going to pick it up, but there's a wear line on these peanut shaped elements, and we look at that to determine whether or not this has been worn too much or not. This shell is our sun shell, and it's quite common for this set of splines that go into the set of splines into the sun shell. It's quite common for this piece here to strip out, and what they've done is they've hardened these splines. Yours doesn't have that problem yet. yet, but it's something we see very often. So when we're doing a recondition, we would replace this shell with the latest shell from GM, and this ends up looking black because it's a hardened piece. So once the replacement shell is put into use, we don't expect it to ever have a problem because they have fixed the problem. But like I say, on this one here, the splines themselves look okay. We don't see any problems right now. On a repair, this is a piece that we could reuse, but on a recondition, we're going to put the best part we can in there. One other common problem that these will develop, a lot of them, is between this shaft and this drum, right down in that surface there. This shaft can sometimes move in and out of the drum. So we always use new transmission fluid down there to air check to make sure that we don't have any leakage here. This one doesn't have any leakage, so what we'd end up doing is putting a roll pin between these orifices that apply this, and that'll stop this shaft from moving in and out forever. So we totally eliminate that problem by pinning the drum to the shaft. This one doesn't have the problem. On a repair, we would not do it. We did previously air check this, and there was no leakage in that area there. So on a repair, we would reuse this piece as is. The pump itself, I mean, it looks fine. There's going to be a rotor and a slide that go in there. We're looking for this area to be smooth. If we have any roughness here, quite often when we put our slide and our rotor in there, our clearance between this and this surface right here will get too great, and we'll have a pump that's not efficient. So we still have to clean it and check on our clearances, but right now everything looks like it's going to be fine there. We do have bushings. That bushing looks worn, so the bushing is going to be this piece that's sitting inside there. This Babbitt style bushing is a little more prone to problems, so we usually would replace that with a bronze bushing at the back of the case. So here's our case here, and way down the back of the case there's a bushing that commonly wears as well. That bushing is going to be the one that this race goes against. It's just from wear and tear that it does wear. So planetary, this is our rear planetary. You can see the gear there. Again, we have to clean it and inspect everything closely, but right now it does look like it's fine. Same thing with our roller clutch. We have springs and rollers inside here that springs are gonna go up against the roller to allow this race to spin one way. So when this is sitting in there, it'll spin one direction but lock in the other direction. So that looks fine as well. And same thing for our front planetary. We don't see anything wrong there. Again, once we clean it up, we'll have a close look at it, but right now it looks fine as well. So that's basically what we found on the inside of the transmission. As I said, Eric or Amanda will call you with the cost estimates and we'll go from there. Oh, actually one last thing. On the valve body, if you look at this check ball surface here, it's beat up a little bit. It's very common for that check ball to blow through the hole. This one's partway through it. The hole really should look like that hole right there. So you can see what that surface looks like, and this one you can see has got a ridge built up. And what we do there is we use a Torlon ball, which is a Chrysler check ball, and that'll stop this wear from happening because the steel ball just beats up on the plate. The Torlon ball will take care of the problem. On the valve body itself, this is our pressure control solenoid. On a recondition, we're going to replace that. We normally would test the shift solenoids. These are the two shift solenoids. And then we're going to have a 3-2 control solenoid here and our TCC PWM solenoid. The codes that you had were for this solenoid, this solenoid, this solenoid, and this solenoid, along with the TCC enable solenoid, which is part of the wiring harness. The odds of all of those solenoids going bad at once are close to zero. So there's one wire that feeds power to each of the solenoids, so we're going to have to look at that closely. But most of the time, that problem ends up being on the outside of the transmission. So, like I said, Eric or Amanda will contact you with the cost estimates, but now you've seen what we see on the inside of the transmission. Thanks.